So we're supposed to maximize profit. Building comes with 50 units, and they are $700 a month. So before we introduce any variables, this represents their revenue, right? But then they tell us you can decrease the price by 25 bucks. Oh wait, increase the price, I should say. Increase the price by 25 bucks. And that should cause us to decrease the number of apartments by 1. Okay. If we increase it by $50, then we'd lose 2 apartments. It doesn't explicitly say that, but this is like a typical problem in mathematics where there's a variable here where x stands for the number of times we change the price. Okay. Okay, so that's the profit function, but then there's maintenance. It's $50 a month for each occupied unit. So this part represents how many units that are occupied, right? If we jack up the price a lot, we're not going to have a lot of occupied units. So we need to take $50 a month it's going to cost and multiply that by the number of units we're going to have for this apartment. Okay, and so I think that's it. That's our profit function. Yep, this is the number of apartments we're going to have. It depends on how many times we jack up the price. We lose 1 apartment every time we increase it by $25. And then they tell us it's $50 a month for each of those apartments that we have. We don't know exactly how many apartments we're going to have in the end, so that's why we have this expression. We can do some algebra. I'm just multiplying these two parentheses together. What is 25 times 5? Oh yeah, 1,250x minus 700x minus 25x squared. Then we distribute that minus 500. Then combine like terms. Oh, we got 550x plus 50x makes 600x. I think I got it. Okay, and then we want to, when we want to maximize and minimize something, we want to take the derivative and set it equal to 0. Okay, this tells us potential maxes or mins. We need to test them to make sure that it's a max or that it's a min. And then you'd also want to test the endpoints. But if we solve here, setting it equal to 0, you're going to get x is 600. Yeah, x is 12. Okay, set the derivative equal to 0 and solve for x. So we need to test that to make sure it's a max and not a minimum. So we plug in 12 into the profit function up there. Okay, so 38,000 on the left. Actually, it'd be easier to plug it in down here, huh? In function. 600 times 12 minus that, plus 325. So I got 36,100. And test a point to the left or to the right just to confirm that it's a maximum. If you know quadratics, you'll know it'll be a maximum. But just to make sure, if you plug in 11, you get 36,075, so it's a little bit less. So this is indeed a maximum. Now that's the number of times we increase the price by $25. To answer that question, what's the price? We'll go back to this parentheses that represents the price, and we'll plug in what we found the maximum to be, 12 increments of $25 increases. So if you simplify that, $1,000 is what it's set for the price.